Hello everyone, I'm Muhammad and today I will explain you the substitution method for indefinite integrals, which is a smart trick that we use to solve integrals that look complicated at first. Firstly, I begin with the indefinite integrals. What's indefinite integral? So, it's big fx plus c. Indefinite integrals means what function gives us this when we take its derivative. So, I mean, if big fx derivative is small fx, then the integral of small fx is the big fx plus c, where c is just any constant. We take c because the derivative of a constant is 0. So, and then when we talk about substitution, we can talk about chain rule. From derivatives. What's chain rule? It's the derivative of function inside function. So f cx, for example. So what's the derivative of this? It's f prime cx and multiplied by g prime x. So I think you're wondering what's its connection with substitution rule. We will see. So the substitution rule. Substitution. So what's substitution rule? The integral of f gx multiplied by g prime x dx. So we can say the gx is equal to u, and if we find the u here, it's g prime x dx. So we have here g prime x dx, and we can substitute it, and then gx substitute u. So what's its derivative? Fu du. As you can see, it's the substitution rule. So, and if we find this integral, it's big F. Here. It's big F Jx plus NC. So you can see that we have the same function. So we can say that the substitution rule is a going backward in chain rule. So I will explain the substitution rule in some examples. So our first example is x cosine x squared dx. So how we can find this? We see that the derivative of x squared is 2x. So we can say u equal to x squared, and then we can find the u is 2x dx. And we can say x dx is equal to 1 over 2 du. So in here we substitute x dx, and we can say that the integral cosine u multiplied by 1 over 2 du. So we can pull the 1/2 outside the integral. 1/2 integral cosine u du, and then what's the integral of cosine u is sine u, and we plug the x back here. It's 1/2 sine x squared. So, and plus nc, of course I forget, but don't forget c. So this is our answer. What we did, we picked u and then find the u, and then substitute, find integral, and plug x back. The next example is integral x over 1 plus x squared dx. So, in here, from the previous example, as similar, x squared, derivative of x squared is x. So, we can take 1 plus x squared as a u. You know that the derivative of 1 is 0. So, the u is 2x dx. Then x dx is equal to 1/2 du. So, take x dx and write this one. So, 1/u. So we can get this by substitution, and then we pull the 1/2 outside the integral. So it's, and I can write this as u to the power of minus 1/2 du. And we know this integral is 1/2 u minus 1/2 plus 1 is 1/2, and then if we divide it by 1/2, it's multiplied by 2, and there is plus c. It's square root of u plus nc, and then we plug x back. It's 1 plus x squared plus nc. Example 3. So it's the last example. X squared e to the power of x cubed dx. So it's a little bit tricky, but we can see that there is x squared and there is x cubed and there is x squared. So we know that the u is equal to 3x squared dx, and then substitute again. But first we can write x squared dx is equal to 1/3 du. Okay, we take this here. E to the power of u multiplied by du, multiplied by 1/3 du actually. So 1/3 du, you can pull the 1/3 back. Du, and we know that the integral of e to the power of u is e to the power of u plus nc, and plug the x back. E to the power of what was our x? is x cubed plus NAC. So, and we find this. So what we did, again, we picked u, then find the u, substitute, find integral, and then plug the x back in. So in this video, I explained to you the substitution method for indefinite integrals. I think it's enough for this lesson. Good luck for your calculus.